Let's look at well, this is kind of really just an aside. I mean, we talked about sets, okay? And they're not the most common data types that you might use in a program, but they're actually there quite a bit. So, for example, this here is Java, okay? And Java has what's known as the Java util collections um, package that has a lot of really useful things like vectors and lists and sets and hash tables, for example, right? I mean, it's trees, and it's got lots of really, really useful things. And here is a hash set. So this is a specific kind of set, okay? So we have here a set of strings. And it's a set of strings, so I can add strings to it, right? This is a kind of an empty set when I create it, right? This generates an empty set of strings. And now I can add Fred, I add Sally, and so now my set has two strings in it, Fred and Sally, okay? This is another way to construct a set that contains Fred and Sally. This is just, that actually looks a lot like mathematical notation. It's just a brace, Fred, comma, Sally, and that's what set one is. This is Python, okay? And Python actually has sets. It's got two syntaxes for sets. Here's kind of my preferred method. Here's another one where we use a list and then convert it to a set using the set constructor, okay? There's other languages that don't actually have sets explicitly, and instead what they do is they reuse some other kind of types. So for example, you might use a dictionary. It's also called a map or a hash, and that's just a collection of key value pairs, right? So Java util map is an example of this kind of collection, right? In Python, this syntax here is also Python, okay? Then you can have a list of elements. This is a list that has the elements Fred and Sally. This is a map, okay? So right here we have a map. Python actually calls it a dictionary. And this thing is just a list, which in Java you might call, actually we do have lists, we have array lists, right? So yeah, that's standard notation for that. And so now what you can do is if it's a list, then you can just go through the list and see if the member you want is in there, right? If it's a dictionary, then you can actually just ask for its value, right? What is the value of sdict Fred? And it'll either give you an error, meaning I don't have a value, or it'll actually give you the number 1. So that's how you know if Fred is in that set. Okay. So okay. I can't help but mention the really kind of a super cool aspect of Python. Okay. So I say some super cool languages, but really what I'm talking about here is Python, which is a super cool language. And this is called a comprehension. Okay. And actually in sets they're called comprehensions. So that is a comprehension. Okay. And what makes it a comprehension is this for p in that. So this is actually equal to the set of 1 over p, right? Such that p is in this range, which means p is in 2 up to 100. Okay. I could write it like that, or I could simply write 2 is less than or equal to p, and p is less than or equal to 100. The 101 is because it goes 1 past, just stupid notation, okay? And p is a prime. Okay. Now this is very similar to what we said before, the set of all 1 over p such that p is a prime. The only thing extra is this part here, and this keeps a finite set, okay? If you don't have that, then it's an infinite set that contains 1 over any prime. And in programming, we don't mean that, right? We just need to stick to kind of finite data structures. So this is actually precisely a set comprehension or a list comprehension. The first one here is a list. This one here is a set. Okay, but it's a way of specifying a set using a property, which is very, very nice. Okay.